This is a flowchart of the scientific method. It starts with observations. Those observations are used to derive a hypothesis about what is happening. That hypothesis is then used to make predictions about future observations. On the basis of these predictions, further observations are made to test the predictions of the hypothesis. If the predictions are not consistent with the new observations, then the hypothesis needs to be modified or abandoned. So you go back and rework the hypothesis. You then use this hypothesis to make new predictions about future observations. You then make new observations to test the new predictions. If the predictions are consistent with the observations, then the hypothesis is accepted. Then it goes on to become a theory. Observation involves viewing and recording, making measurements, and conducting experiments. This is the collection of data. An hypothesis is a tentative explanation of an observed phenomenon used to make testable predictions. Predictions are produced by applications of the hypothesis about future observations. They must also be unique, since a prediction from two or more hypotheses can't distinguish between the alternatives. Testing a hypothesis involves making observations based on that hypothesis to see if its predictions agree with the observations. As an example, take the observation of a known particle of negative charge, that is, both the mass and charge are known, is observed to follow the path as seen here. The hypothesis is that a small particle of positive charge is at the center of attraction. This is similar to the way the atomic nucleus was discovered. The prediction of the path of a similar positively charged particle, that is, same mass but opposite charge of the first particle, should be deflected as seen here. If the prediction occurs, then the prediction succeeds and the hypothesis is supported. If, however, it follows the same path as the other particle, then the prediction fails and the hypothesis is falsified, so a new hypothesis is needed. The new hypothesis is a small, neutral, high-mass particle, possibly a mini black hole, with a high enough gravity to bend the particle's path. The new prediction is that a similar neutral particle should follow the same path as the other two particles. If the prediction occurs, then the prediction succeeds and the new hypothesis is supported. Now, the scientific method is just a general description. It works best with controlled experiments which can be tested for particular predictions and where variables can be controlled. It does not always work well for real-world observations. This is because variables often cannot be controlled and it is difficult to test for particular predictions. Furthermore, it does not always work for historical sciences. This is because variables often cannot be controlled, and observations often cannot test for particular predictions. Destruction of evidence is also common. This can be natural, but it can also be man-made, including by scientists. This destruction can be both accidental and deliberate. As a result, it is not always used exactly as described.